So good afternoon, everyone. The title of my talk is Supercharge Kotlin apps, the power of inline functions. And you see my little cartoon that I created to illustrate the title of my talk. Yeah. Oh, okay. So I'm just going to introduce myself in the form of an elevator pitch. So I'm just going to tell you who I am, what I do, and why I do what I do. So my name is Jessica Randall. I'm from Cape Town, South Africa. So I flew all the way from Africa to be here today. I'm a GDG organizer for Cape Town, a Women Tech Maker ambassador, and need to be volunteer executive. So I do lots of community work. I'm a mathematician by profession, Android dev by hobby and curiosity. So that's a lot about who I am. What I do Android technical talks, and I'm an Android developer, and I'm a mathematician. So basically I solve complex, abstract, pure mathematics algebra. And why do I do what I do? I find Android very interesting, and it's cool, and I like the challenges. Maths is also interesting and cool, but in the abstract world, it's more beautiful. So that's why I do what I do. And yeah, that's all about me. Oh, and then if you want to get in touch with me or give me feedback, please, I would greatly appreciate it. You can contact me via these platforms. On X, I'm at JustJessZA. On Instagram at mathsgeek199813. I also have a Mentor Me in Tech blog where I just give like mentorship advice for people starting out in tech or doing transitions. And on LinkedIn, you can just use my name and you'll be able to find me. Yeah. Oh, sorry. So I'm going to just give you a brief overview of what my talk will entail, and then we'll get to the slides. So I will be discussing what are inline functions, where you would best use them, and then I also give a demo of where I use them. They are very simple demos, just a heads up, but the concept can be applicable to diverse, more complex situations. And then I also dive into inline properties in Kotlin as well. So that's an overview of what I'm going to plan to be doing. So how do they work? So I know all of you guys are developers or more or less technically inclined, right? So you all like shortcuts, right? Anyone know like Control-C, Command-C, Control-V, Command-B? So everyone likes shortcuts, right? So basically what an inline function is, it's a shortcut to the function that you call within your code. And this is how it makes your code run fast in two ways. So there's no extra steps. So basically when you create a function in Kotlin, you say fun and then define your function and then you call it somewhere in your code, right? So when you run your code, it goes to where you called it, right? And then it must still go to where you defined it. So it has to run to where you defined it, execute it, and then come back and then follow the rest of the code. So there's no extra steps with inline functions. It just takes where you define it and directly paste it where you call it, basically. That's what happens. And then number two, there's no waiting around. So it doesn't have to wait for you to come back to run the rest of the code. So usually what happens is you'll define your function and then you call your function, and then when it's called, it must go back to where you defined it, execute it, come back, and then there's like a detour that comes before it comes back to run in your code. Yeah. So there's no extra steps and there's no waiting around. Sorry, what is this thing? So what do they best work for? So they best work for lambda expressions and higher order functions. So lambda expressions, because a function can take a lambda expression as a parameter. So, and then lambda expressions are like on the spot mini functions, right? And then you can have many different lambda expressions that can be considered as parameters for your function. So that's what they work best for. If you think about it, if you pass like 3 different lambdas, you would hate for it to first go back to where you define each different lambda, execute each one in a specific order, and then go back and then execute the whole code again. That's basically what happens. And then every time you call lambda, it creates an object in your code. And then it keeps on creating more objects every time you use it. And then just think about if you use it in a loop, then you wouldn't want it to go see it and then go back and then go back and then go back. So that's the idea I'm trying to paint of where you would use them for lambda expressions. And then that was best for higher order functions. So higher order functions are when you have a function that takes a function as an input or gives a function as an output. So for example, if you want to work out, let's say the derivative of something, then you would give a function and then you still tell it to derive, or you give a function and then say you want it to derive the function, then you pass the function that you define to derive that function within that function. So that's an example of higher order functions. So if you think of anything that's computationally intensive that uses functions, that's most probably where you would use inline functions just to help you make the code, help make you read the code easier. Sorry, I'm very bad at this. So this is just a simple example, but it's just to illustrate what it does so that you can get a full picture before I go to the real world examples. So basically, we have a function called load, and it takes onEnd as a lambda argument. So it will simulate that something is loading. And then once the loading is done, it executes the lambda, which is onEnd. And then when you call it in the main function, you'll call the function load, and then it passes the lambda function. And then when the lambda function is done executing, it will print done. So this is just a very simple example, but it's just to show how it works with lambdas and then what it does when you inline this function called load. So this is the basic concept idea, but it shows the concept really well, so I thought it was relevant. So then what we do is we inline this function. So the only thing that changes in the syntax is you use the word inline in front of the function. So you have inline fun, load, and then you have your lambda. And basically, when you inline the function load, it executes the lambda onEnd after completing its operation. And then when you call it here, and you call load, it will just print done because you inlined load already. So there's no extra, there's no passing the lambda and then done. Can you see the difference? So like here, it must still pass the lambda. Here, it calls load and then it prints done. So the lambda is already done within this function. It doesn't still have to pass the lambda and then print done. So it's like a direct pasting of the lambda function within this section of code. Sorry. So you're probably wondering what are the benefits of inline functions. So there's no extra steps. So if you think of a very big code base and you have many functions defined, and you think of those many functions that have many different parameters, and you use them a lot, and you just want it to be like straightly executed, that's where you would use inline functions. So no extra steps for critical functions. Faster code because it doesn't have to do a detour, so it's not like it goes through the function, like you call the function and then I'm still find in the code base where you define the function and then still execute everything you define in that function and then go back and then go execute the rest of the code. So it is faster code. And it does save memory because every time you call lambda, it creates an object within your coding file, and then if you call it many times, you create many objects, and that causes overhead within your code. So that's why I have Sonic, so faster code and no extra steps. So some challenges for your inline functions. It does make your program bigger. So because everything is pasted with, everything's directly put into the function that you put in. So it just makes your code a bit bigger. It's not always useful, so you have to be very careful when you use it. You have to like ask yourself, do I really need this? Or do I want to have to use it? Or does it look nice to have to use it? So you just have to make sure that you use it for things that are relevant. Don't inline every single function that you come across. Like, that's not the point of inline functions. It's to use it where you think it would be necessary to use it. So it can slow things down if you inline every single function, because it's pasting every single definition of the function that you put where you call the function. So it will slow it down, but that's why you're supposed to use it when it's useful for you. Okay, so I created a small application. It's very small, it's very basic, but it's a calculator app, and it only takes 2 values, but it's just to give a more realistic view of using it. And I just focused on the sections of code that was relevant, but it's just to show that you can use it for something realistic. Very, very basic, but I'll go through the code with you. So I have what you call perform operation. It takes, I use double, so it just means that it's got 2 decimal points in the end. So it takes a number double of type double, A and B, and it performs an operation on it, and it will give you, it will return a double, or it returns the operation of what you do with the double. This is my function. I did perform operations, and then these are the basic arithmetic operations for the lambdas. So I just defined it as, I just did the basic add, subtract, multiply, and divide, and then also catered for null because I don't want it to give me errors. So yeah, I just created these lambda expressions, and then you'll see when you go to the calculator and you type in, let's just say, for example, 7 times 6 is 42. What happens is when I perform the operation, it will go here, it will look for the multiply, and it's almost like this is pasted there, and then it performs the operation within that it takes the lambda there and it performs operation within the inline function. But basically, the reason why I thought of a calculator is because you will use many different numbers on a calculator many different times. You use operations almost infinitely many times. And then when you use something infinitely a lot, you would want it to be very fast and do it like immediately. So that's why I thought of a calculator with lambda expressions to inline for my lambda expression example. Demo, yay! So I just did like a quick demo of the UI, just so you guys can see what it looks like. I unfortunately do not have Android Studio on this laptop, so I had to do everything on different, like a MacBook, and then transfer everything. But if you are interested in the full code, I will make sure that it is available to you. This is it, 7 times 6, 42. And then I just made sure that all the other buttons worked, obviously. Okay, so, and then I also did an example for higher order functions. So, as we know, higher order functions will take a function as input or return an output as a function. So, I just looked up a simple example. So basically, I just created an app that displays a list of transactions in like dollars, and then I wanted to apply different discounts to that application, but then what I wanted to do is create a function that takes many different functions as input and gives you an output, outputted values. So basically, I called it discount app, but basically this is the process called transactions. So I put everything in different files. So you have transactions, which is just the list of transactions that I have, like data, and then we have a discount. This is the discount function, so it will take a double, perform a discount on it, and then returns another double with the discount applied to that value, to that double value. And then then you have the list of transactions, and then it returns the transactions with the discounted amount as a list of transactions again. So that's basically how this works. And then I inlined it so that the discount function, when you run it, it won't like look for the discount functions, which is in a different file that I saved it as. When I'm kind of modularized this app, it will just go directly to here, and almost like the discount function is pasted within this. So when it does all of this, it does all of this at once. Everything is needed within this higher order function. Yeah. And then I also did like a demo of it. It's very like fast, so yeah. So I did the 5, I just showed everyone 10, 15. So it updates all the things. And there's still some stuff I have to fix on it, but the discount does work, and the function does do, it does work, the discounts based on the original amount, which I just had to make sure that it did. The UI is still a bit questionable, but it works. Okay, so now we're going to just speak about some inline properties. So basically, the whole analogy of an inline property is, imagine you have a toy that you want to get out from your toy box, right? Each time you want to play, but you don't want to always get it. If that makes sense, you want someone else to do it for you. So you can do this by using a getter and a setter function. So Kotlin doesn't have what you call doesn't have backing fields. Or it has it doesn't have backing fields, so it has what you call properties. So you can change the properties of things with getter and setter functions, and then you can also inline these getter and setter functions, which is quite cool. So, for example, say you have a function where you get a toy. So you get the toy, and then you want to use a getter function to get the toy. So you can inline it to get the toy every time you want it. And then you want to change the value of the toy. So you'll set the value, let's say we want the toy to be yellow. So you'll set the value of the color of the toy to be yellow. And then you can also inline the set function for that. So yeah, the concept is basically, instead of asking someone to get you the toy or change the toy, you can directly grab and get the toy and change the color of the toy that you want. So basically what Kotlin inline properties allows you to do is you can inline the getters and setters for your code, where you can directly access a property or modify it. So it doesn't have to be a toy. It could be a name. It could be an email address that you want to change. It could be a color of something that you're creating. It could be anything realistic, but that's just the basics of where you would use it. So you can use it in properties of your code if you think of anything that you would like to do. You can also use it there. So this is just an example of how to use get and set. But you can also inline these functions. So I have a class of a person. I have the name, which is the property, John. I can get John. I can set the value of John to be something else, like Jenna, Jessica, Karen. And then you can also inline these get and setter functions so that when you just call the property, all of those are done. I mean, the get and set is done where you call them. Yeah, so it's just directly done. You're just directly updating or setting the value of your property in Kotlin. Thank you for listening to my talk. This is the first time doing this talk, so I'm open to as many questions and feedback as possible. And yeah, thank you for having me.